It's Mega Mailbag. This wooden crate is a foot deep, a foot tall, and a foot and a half at least wide. It's overflowing with mail, and I have still other stuff kicking around. I think it's time to expedite opening and putting this stuff to use. Up first, for all the way from Germany, it says PC drive. Now, I don't know. Let's see how accurate that is. So PC drive kind of looks a DC to DC converter, LM2596. Well, let's open this, get a better look. So it is clearly a DC to DC, and I guess, are they trying to tell me input, output? LM2596. Adjustable buck converter, step down. 1.23 to 30 volts, LM2596. 99 cents from Auto Industry. And there it is. Inputs, outputs, adjustable trim pot. So the input can be 4 to 35 volts, and the output can be 1.23 to 30 volts adjustable with a maximum 3 amps. So double checking the specifications here for in and out voltage and the current. It switches at 150 kilohertz if that's going to be important to any application, especially if this is going to radiate any noise and EMI has to be taken into account. But for just bench hobby work, as long as it works, it's usually good enough. So the adjustable version of this chip, because you can get fixed 3.35 and 12 out as well as adjustable, the adjustable version can go 1.2 to 37 volts out, plus or minus 4%. 1.23 to 30, well, I don't know why they decided to present it that way, but close. 3 amp load current, and the input can be up to 40 volts, but what's the minimum? Well, the operating conditions, supply voltage, minimum 4.5, max 40 volts in. So this module claims to be able to go down to 4 volts in and only 35 volts in max. So a little bit of discrepancy on that minimum input. One way to find out is to eventually test it, but for now I just wanted to double check the basic functionality is in line with the datasheet. I've been ordering various copper wire spools. Okay, so it looks like I ordered some heavier gauge and some thinner gauge here, not quite magnet wire. This says 26 gauge, 30 grams worth, and this is 30 grams of, well, 0.6 millimeter diameter versus 0.4 millimeter. What I want to do with the thicker wire is maybe try winding some inductors, experimenting like that, and the thinner wire, when I receive it, is going to be maybe for winding electromagnets or motor experiments. For the enameled copper magnet wire, I bought a couple from Mercury Shop 2007. First, I got this 26 gauge, which is 0.4 millimeter diameter. Comes in a spool, not based on length, but on weight. So it's about 30 grams, 1 ounce. They're saying it's approximately 27 meters, I think. $3.67. When trying to look at all the copper spools available and looking for the best deal and all of that, and this one has free shipping, I think I made a reasonable choice, and this comes from Bulgaria. But after a while, you get exhausted trying to compare all the different options, so I just ended up going with this one. And from the same seller, I also bought 22 gauge, 0.6 millimeter diameter, 30 grams again, about 1 ounce, about 11 meters, $3.67. So for the same price, you change the gauge up and you get the same amount in weight of copper, and the length is going to vary based on the gauge. That says NCH 6100 HV, high volta. I think I know what this is. Let's find out. I've been wanting to experiment with Nixie tubes, so this might be my high voltage power supply. Nixie clock home. Yeah, NCH 6100 HV high voltage power supply. So it comes with some 0.1 inch headers and what looks like those fancy terminal blocks. This feels like a more rugged, thicker board, heavier duty, maybe more expensive board than usual. Maybe it has to be for high voltage. And they certainly have the warnings on there, caution high voltage. So we got DC 12 volt to 24 volt in and DC out 85 to 235 volts. A big 10 microfarad 400 volt surface mount capacitor. The typical switching inductor, miscellaneous stuff. And this, I guess, is the voltage adjust. It says clockwise voltage rise. The Nixie tube power supply, NCH 6100 HV. This was $11.95 free shipping from LoveCell 2013. So this is a DC to DC step-up converter. It takes 12 to 24 volts in and gives out 85 to 235 DC volts set by the trim pot. Designed for Nixie tubes and other similar things. I only just want to quickly see if this works or not. I didn't look into what parts are in use on this board and what the specs are. I just wanted to get this up and running ASAP, so a quick functional test will suffice. So because getting up at $12 sounds a bit expensive for our usual mailbag purchases, just doing a quick search on that board part number on eBay and sorting by the cheapest price plus shipping, well, $11.94 is currently the cheapest, and it goes up from there. So, all I need now is some Nixie tube stuff. From the Ukraine, it looks like we have indicator lamps and sockets. I'm hoping this is what I think it is. I need to find the right way in. How about here? It's very difficult. I'm used to opening envelopes. Let me just see what I can do. Brute force. Looks like Nixie tube sockets and Nixie tubes. So it looks like we have 6 tubes and 6 sockets. So these were desoldered out of something. You can see the solder in there and slightly bent pins, to be expected, but they look fine, so I hope they work fine. And the tubes. All right, yeah, this is really heavy-duty, good wrap. So I got 6 Nixie tubes and 6 sockets. I can't remember how I decided I wanted 6 of these. Maybe to do a 6-digit counter of some kind. I don't plan to make a clock, at least not right now, but I might want to make a counter. I bought a set of 6 tubes with 6 sockets, and it says the condition is new and tested, but it does say down here the sockets are used. Either way, it's new old stock, so there's only so much you can do. It's from Vintelec 7773 from the Ukraine. And this set of 6 tubes plus sockets, $17, and the shipping is extra, $12.50. So adding all this up and looking at it divided by 6 and factoring in there are sockets, again, just like the copper wire, you do the best you can and you look at the prices of if you buy just an individual Nixie tube of the same model and no socket, and look at the price of that versus all of this lumped together. I did the best I could. I didn't research it again right now to double check. So if it's IN12A, let's look at those. From hackaday.io, there's a blog entry on the IN12A. This is from 2014. So they're saying, at that time, the price is around $20 US for a lot of 6. Well, I paid 17 US for a lot of 6 with sockets, but 12.50 shipping. So I don't know if they are thinking with or without shipping, but whatever. So pin 1 is the anode, which will be the common for all the elements. And they're saying here 170 to 200 volts DC would be the voltage. And then pins 2 through 11 are the other individual numbers. And those will be cathodes. So pin 1 is marked with the arrow on the Nixie tubes I have. So that's where I would put my high voltage output, and then I would ground all the others to light up the elements. It does need a current limiting resistor, and here they're saying the current is going to be around 2.5 milliamps, which is nominal for this IN12A. Now I've read elsewhere in general it could be anywhere 1 to 5 milliamps for any given Nixie tube. So in my case I happen to have a 22K resistor on hand, and I threw that in a circuit very similar to this. So just for a quick test of the Nixie tube, I have the high voltage power supply here with about 14 volts in arbitrarily from a DC bench power supply. The positive high voltage out, I set it at 150 volts because that's what seems to work best right now. And I'm going through a 22K resistor for current limit. And I connected that to the anode pin on the Nixie tube, which is being held up on an angle by blue tack. Otherwise, the weight of the cable was making it fall all over the place. The common output of the high voltage supply is just going to this alligator clip that I can use to ground each electrode and turn on the various digits. The input voltage measures 14.3, and the output voltage is set at exactly 150 right now. So if I take the ground of the high voltage out and touch a terminal, I get a digit 1, 2, 3, 4, 5, 6, and so on, which is hard to see at this angle. For now, I just want to do some voltage measurements. So if I stick it on the 3 and check the output high voltage again, we still have 150 volts out, and on the other side of the resistor it's 126 volts. So that's the anode of the Nixie tube. So that means there's what, 24.7? So that looks like 24.7 volts. 24.7 volts divided by 22K resistor. It's about 1.12 milliamps. I've added a current meter in series and 1.12-ish milliamps in series with the anode of the Nixie tube. So that's how much current I'm using to get this to light up. So this blue tack is also good for suspending objects in the air. So I'll see what I can do about accessing the pins. There's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. This says it is a universal prototype PCB for 7, 8, and 9 pin valves. I wonder, is this my normal standard vacuum tube experimentation kickoff? Yes, it looks like vacuum tube socket board. Also heavy-duty feeling boards. I guess they need to be robust to handle a tube being inserted and removed, and possibly high voltages. But I don't have any tube sockets yet. I do have some vacuum tubes, but I need the sockets. So this universal PCB, they're marketing it for tube amplifier valves or vacuum tubes. There's a couple of sets of pins, an inner and an outer, so you can have a 9-pin tube, or I guess a 7-pin tube. You would put the tube socket on here and you have all these through holes that you can custom configure how you want this to go. I liked this idea better than some of the others that were more restrictive, and I think $1.99 seemed good when I was comparing everything else available. This is from Thanks to Buy. You're welcome. It's made of exquisite FR4 double-sided board. Hey, it's 2 millimeters thick, so that's thicker than the usual 1.6 or so millimeter board, and so it's not easy to deform. That's true, it felt really robust, heavy duty. Like if I install or remove a tube, it's not going to flex the board. All right, it's been a long time since I ordered a plastic patch. So, what do we have? ICs, ULN 2803. This kind of sounds like Darlington high current output driver chips. Quantity 10 of ULN 2803 Darlington transistor array. 10 pieces, $1.12 from Module Fans. So the ULN 2803 transistor array has 8 channels of in and out, where you can use a logic input and control 50 volts, 500 milliamps at the output. So it's meant for driving things like relays, lamps, and they have protection diodes, so if you trust what's on board here, kind of like having an 8-channel diode protected transistor driver that you can hook up a logic input to in a convenient package. So you don't get 500 milliamps simultaneous on each of the 8 outputs if you turn them all on at once. This is only for single output. So here they're showing a typical application for an inductive load. They have, I don't know, this could be anything, 3 phases of a motor or something else with its own external supply voltage. 3.3 volt logic, and they are bridging some outputs together, I guess, to get more drive current on each channel. 2 channels bridged, 2 channels bridged, and then 4 channels bridge for some other node. And it's an inductive load, so you don't need, according to this, any other protective diodes or such. So that's the general idea for this. Logic in, higher power driving capabilities out. And to figure out how much current can be controlled on various outputs that are going to be on at the same time, in their design example they show how power is V times I, and however many channels you've got on with a certain voltage and a certain current, you don't want to exceed the power dissipation of the chip. So you use things like this in the datasheet instead of just assuming you can control 500 milliamps times 8 outputs. This one says plastic clip, which I guess is what you would use to hold the plastic patch in place. But are they really compatible? Let's see. Oh! Now I don't know if this is LEDs or photodiodes, phototransistors, photo anything. Light emitting, light receiving, light deflecting. How do I find out? Well, I don't know if I would break one by throwing it on a battery, but let's consider sacrificing one. If we break it, we'll hook it up to the power supply later and blow it right up. Do it right. Doesn't work there. Doesn't work there. So it's a photo receiving device of some kind. Let's see if we can track it down. Quantity 20 photodiodes, 99 cents from Z-Home 2015. There's really not much in the way of specifications here, just the size of it. So, photodiodes. I guess I'm just going to experiment with these, maybe use them as on-off switches when detecting light, as well as see if I can get some analog comparator control circuitry out of these things. I'm not sure if I've ever had photodiodes before, so now I do. Unless I broke a couple of them trying them out with a battery thinking they were LEDs. Well, that's why you get 20 spares. It says capacitor 680, 25 volt. And here they are. I know I've ordered multiple values, so I guess I got them in different places. Just restocking the part trays, you know. I have so many of these now, gotta fill them up. And it says, yeah, 10 quantity, 25 volts, 680 microfarad. So there we are, radial leads. I bet this would be a long delay on a 555 timer. Maybe I should try that out. Do like a 2-day delay or something. Blink an LED on and off once every couple of weeks. 10 aluminum electrolytic capacitors, 680 microfarad, 25 volt, $1.29, Robot Maker 2015. Sounds like a good deal for 10 of these, huge value. Beyond the basic label spec of 680 micro at 25 volts, I don't really need anything specific, it's just for playing around on the bench. This has the words expansion module several times on it. I hope it's several times the fun. What do we have? Oh yeah, there are lots of boards. So it looks like there's several different kinds, and they are all surface mount ICs to 0.1 inch header dip breakout packages, so we can maybe breadboard these. So you take a surface mount 14 or 16 pin chip, or even smaller if you have it, and you just use whatever pins you need. Then you can plug it into a breadboard. These finer pitch looking ones are where it's really going to be helpful. From Alice 110 1983, I got a couple of these adapter boards for SOP, SSOP, etc. surface mount chips, breaking them out to 0.1 headers so I can use them on breadboards, or otherwise just wiring up directly to them with or without pins to make it easy. It's just a base plate to solder the surface mount parts onto. So I got a few different configurations to be able to handle a wide variety of surface mount chips I might encounter. Break them all out into 0.1 inch headers. 99 cents for 10 pieces of each of these sizes I wanted. This says nail tool. It's pretty big. I think I know what this is. I wanted a fancier looking alcohol dispenser than keeping the big pharmacy bottle around. So I ordered a couple of these things. I've used them in the past, and they are very convenient. Yes, that's what it is. So you fill these with rubbing alcohol, isopropyl alcohol, or whatever else, maybe even flux, I'm not sure. Whatever you want to dispense. It's got the pump tube. You assemble it. Then when you want to use it, you flip open the lid. And if you have a swab or something you want to use, you would press down on this and the liquid comes out and you can use it for whatever you're cleaning or working with. So to put one of these to use, take off the lid. It looks like it's got markings. It can hold 180 milliliters up to here, so probably 200 milliliters total. Throw that in there. Put it all together. And now let's say there's this board. There's this little something here I feel I want to clean off. Flip the lid on the alcohol. Pump it up. It comes up to the surface. Close it so it hopefully doesn't evaporate. And do what you gotta do. Clean the board. And relatively, that spot's gone. I think I've destroyed the swab running over the terminals and stuff. It's a small thing, but it makes life a lot simpler. 200 milliliter pump dispensers. They are marketed for nail polish remover liquid, $1.57 each. From Min Min 44,650. So it says they are brand new, they are white, they are plastic and stainless steel, and can hold 200 milliliters. And I've used these before, mostly for the isopropyl alcohol, where you have this container with a flip down lid to minimize evaporation. No need to stop what you're doing, especially if you've got stuff in your hands and you don't want to use two hands to unscrew a bottle, and it's just right there available. description of contents on this says, electronics. Well, let's check this electronic stuff out. What could this be? I have no idea. It could be anywhere from December till now, a couple of weeks ago ordered. Ah, more flat flex cable breakout boards. 24 pin, 1 millimeter, 0.5 millimeter. Score! 5 of these, $2.36 from Servo 2014. Not much to say that I haven't said before, and I probably have more on the way still. This one's described as copper wire, so it's probably the same day I ordered all this enameled copper wire of various thicknesses. Which one's this? It looks like a spool here, the ends of it like this, and the wire wound in here. Yep. Even more enameled copper magnet wire. This one is 0.2 millimeter diameter, and it says it's 100 meters. $2.29 from 94 Racing Us. It's got red enamel on it. So if it's 100 meters of 0.2 millimeter diameter, what gauge is that? Well, according to one quick internet search, in millimeters, if we're looking for 0.2 millimeters, it's about 32 to 33 gauge, something like that. So, I wanted various diameters, and this will be one of the thinner ones to have on hand. And this says it is wire strippers. Oh, that's not wire cutters, that's a knife. I bought this to go along with this, so if I'm feeling blue, I can use this one. And have some spare blades. Kind of awkward to get into. Finally. So it comes with a protective cap, of course. There's not much to say about it, it's just another hobby knife like the black one I've been using, but I wanted a spare and some variety. Hobby knife with 6 blades. I wanted this blue fancy looking one, and they do come in different colors. I thought blue was the best one for me. $1.69 from Mike, LI 2013, Mike Lee 2013 maybe. So it's stainless steel, weighs 50 grams, and not much to say about it. I've added this to the Mailbag opening utensil family. BNC male to female splitter. I believe this is what I bought for the oscilloscope to plug in and allow, yes, adding terminators on the end. So if I have a signal generator and I'm using it in 50 ohm mode with a BNC to BNC cable, and I want to plug it into the oscilloscope, it would be good if I could also plug a terminator in here and plug this into the scope with the function generator plugged in here, and then see hopefully a better waveform. Having a handful of these is a good idea. Quantity 5 BNC male to 2 BNC female T-splitters. They're marketing it for closed circuit television camera DVR adapters. I guess 75 ohm coax stuff might make good use of this. $1.89 for 5 from Top Electronics 2010. Now this one is a little concerning, if not bringing about a lot of curiosity. It's labeled as sunglasses, which I did not order, but if I had, I'd be very concerned. I am very curious about this. It feels like, is there something here that I might cut? Where can I open this? Over here. I have to see what's in here. That is not sunglasses. Those are crimp terminals. Maybe whoever packaged this was wearing such dark sunglasses they didn't realize what was going on. So, I ordered several different sets of these kinds of connectors because I recently bought a terminal crimper for this style of terminal. So these are for heavy gauge wires, possibly useful in automotive, like wiring up speakers or anything like that. So you could have butt splices, and in this case, this is a set. So you crimp a heavy gauge wire on one end, and then you've got male and female contacts. So 100 for $239 from SST 903. So it takes cable that is 16 to 14 gauge. You get 50 female, 50 male, and you would take that 16 or 14 gauge wire and crimp it in here, and then you can have a disconnect. Probably good for things like automotive electronics or testing things with higher current on the bench, connecting up a load in and out of circuit with speakers and amplifier testing. So a big pile of those. This is labeled as electronic parts, but it also says speaker module. Now I've seen that label before, and it was not a speaker module. I wonder if this one is. Nope, looks like flux. Solid rosin flux. A typical little container for 99 cents from Alice 110 1983. So this is 22 grams including box. And I guess you can use this to clean the tip of a hot soldering iron, dip it in there and let it do its thing. Or you can chip away some of this and mix it with isopropyl alcohol and make your own liquid flux. I will probably try both. This says something about a 9-volt battery holder. I know I ordered a bunch of different battery holders maybe months and months ago, and I'm sure they've been here for months and months, so I'm finally getting to those. This one looks like it's got some power cables. I figure working at things on the bench with breadboards or whatnot, sometimes it's just not convenient to power up the power supply and look for all kinds of leads. So it looks like I bought 2 of these. It looks like they hold a 9-volt battery. Sure enough, they have an on-off switch on the back. And I believe this is a 2.1 by 5.5 DC barrel jack. 9-volt battery holder with on-off switch and 2.1 millimeter DC plugs. 99 cents for one. From CZB 672 1960. Very straightforward. You throw the 9-volt battery in and close the cover if you want. It looks like it can have an optional screw to keep the cover closed, but it didn't come with one. And this one that I bought has the DC plug on the output, as well as the on-off switch on the back. That says trim pots, and it looks and feels and sounds like they are in a plastic container, which is going to be very useful. There they are. So these look like nice breadboard-friendly precision multi-turn pots. Yes, a perfect match. So these would be very handy to have around for op-amp circuits, especially using them for set point control. 3296W kit of multi-turn trimmer pots. $5.63 from Deep Learnings. Comes with a total of 50 parts, 10 values, and 5 of each. And it looks like I barely put a dent in that big wooden box. So let's keep going. This says 1 module. What kind of module is it? It's one wrapped in foam and an anti-static bag, if I can get in there. Shortcut. Oh, this looks like a stepper driver. L298N. Sounds familiar. So it's kind of hard to read all the silk screen, but it looks like we have out 1, 2, 3, and 4. And then we have 12 volts, ground, and 5 volts. and then it looks like Arduino sort of friendly enable, and then in 1, 2, 3, 4. And there's some markings on the bottom confirming everything except those 0.1 inch header signals. Now there's also this vertical position jumper on each side, and I don't know what's happening there. The one jumper is on the enable labeled input. I don't know what this means. Can I take the jumper off and control it myself? But what's this one over here? I don't see a marking. L298N dual H-bridge stepper motor drive controller for Arduino, it says. $1.74 from 6999694. So they do have a heat sink on this driver, which is good. And they are saying it's an ST branded L298N. So it can drive a 2-phase stepper motor, or a 1 4-phase stepper motor, or 2 DC motors. It's got a built-in 7805 regulator to power the logic side of things, but they do say if you're using more than 12 volts in for power, use your own separate 5 volts. So when I'm ready to use this, I'll have to look more into it. But for now, just to get a top-level understanding of this 298 chip, well, here's the ST data sheet. And they do say operating voltage up to 46, total DC current 4 amps. So going back to the listing for this specific control board, they're saying the drive current would be 2 amps max for single bridge. Looking at the data sheet, they have a little circuit here that says winding current up to 2 amps. So if this is a bipolar stepper motor, here's the stepper motor windings. Here's one circuit of 2 amps and another circuit of 2 amps. And flipping around the datasheet for the chip, if you want to break a motor by shorting the terminals essentially, then the absolute maximum of 2 amps must be followed on the channel. But this is a little confusing. When repetitive peak current is needed greater than 2 amps, a parallel configuration can be used, like figure 7. So in figure 7, output 1 has 2 outputs together. Output 2 has another 2 outputs together to share current load. But in general, if this is saying it's capable of 2 amp max, I'm probably going to use it way below this. I'm not going to try to stress it out. So as usual, I bought this because I saw it and figured I can put it to use. No specific project in mind right now, but when I get all of this stuff piled up together, surely something will happen. I'll come up with all kinds of projects, one big monster thing. It looks like I bought all the combinations of male to male, male to female, and female to female, so I can do whatever I need to do plugging one thing into the next. And these are probably what, a 6-inch length? So I think the previous set I bought long ago was longer, and I thought for going shorter distances maybe I need a pile of these. In they go on the breadboard with the male side, and obviously the female side nicely mates on the controller. There you go. Short distance, cleaner, neater, everything's good. 120 total pieces of all variations of male to female, female to female, male to male, $2.83 from 2009 Shopping Mall. This one says expansion board module and LED custom patch. I'm intrigued. I'm running out of room to cut these things open. So what is this? It's colorful. The right-angled 0.1 headers are sloping down a bit. It's got miniature screw terminals. big electrolytic capacitor, big 1000 microfarad 10 volt electrolytic. Looks like I2C pins, ground and power on the back. It's a 16 channel 12-bit PWM driver. Well, let's look it up. PCA 9685, 16 channel 12-bit PWM. They're saying this is a motor driver I2C module. It's $2.58 from World Chips. But as much as they are saying it's a PWM servo motor driver, this is actually an LED controller chip doing PWM, sure, 16 channel 12-bit I2C bus, but it was designed for LEDs, and all the features are here somewhere throughout this data sheet about how you can control the channels and set the frequencies and all of that. I guess in the end, it's just a bunch of PWM outputs controlled by I2C. So yeah, you can control whatever you want with it, but they're marketing it heavily for LEDs. I guess we will see if we can do servo control with it. Also from that same shipment, oh, this is a pile of stuff I can see. I don't know if this is a kit. Whoa, it exploded. Okay, it's not a kit, it's just the rest of the things I probably ordered, all at the same time. So these look like the actual terminals that go into these connector housings. And there's male and female ends, so I'll have to figure that out later. Crimp pins for making DuPont jumper cables, 100 pieces of female, and 100 pieces of male pins, each 99 cents from World Chips. Not much to say about these, you just crimp your own wire on and make your own DuPont male or female pins. I bought the female housing, 100 pieces, 99 cents World Chips, but I didn't see a male housing, at least at the time, so I just bought this for now. And for the male side, worst case, if I need to crimp my own, I can heat shrink it. And this looks like an LED with a whole lot of pins. So I guess it's a red, green, blue LED with one common and 3 discrete controls. So it looks like a standard 5mm diameter and 4 terminals on it. All right, I've put all the pins in a breadboard individually. Maybe this is a good time to use male-to-male DuPont. Now, that's kind of top-heavy. So, blue tack to the rescue. What did I say I bought blue tack for? So I can keep something in place when it just isn't possible any other way that I can think of. Now that's pretty stable. So with the button cell test, what do we get? So after some trial and error, it looks like the yellow pin, which is the second LED terminal from the left, the way it is here, is a common anode. So if I keep that on there and individually or all together, hook the other wires up to cathode, red, green, and blue, but it looks whitish on the camera from where I'm looking. So if I try to turn them all on, yeah, it's kind of like cyan or something right now, and red then dominates the whole thing. So maybe if I had some sort of diffuser to put on there, even a sheet of white paper, I wonder if that would do any better, but I can see the individual LEDs inside coming on as opposed to color mixing. 50 pieces of 5mm diameter RGB common anode LED. $2.04 from World Chips. So common anode and then individual RGB controls. It's a clear case, 5mm, and the forward voltage, depending on the color, between 2.1 and 3.4 volts. Viewing angle 25 degrees. And here's the various brightnesses of the LEDs. And here's the breakdown of the color wavelengths for the red, green, blue, and the brightness you get and the forward voltages for the individual ones. So from all of this, I'm not sure how to figure out exactly the safe forward operating current the way this is all written, but it looks like forward current 20 milliamps, 20 milliamps, 20 milliamps, even though what does this have to do with angle in degrees and some VR is 5 volts? And yeah, I don't know what they're trying to tell me here. Well, I still have more stuff in this same package, okay? A bunch of 8-pin dip chips. Looks like I got 20 LM393s. 20 pieces of LM393 comparator. Looks like it has a National Semiconductor mirrored logo. I guess they mirrored the whole chip picture. 99 cents for the 20 from World Chips. And they are new and top quality, of course. So it contains 2 independent precision voltage comparators, applications, limit comparator. You can generate pulse, square wave, and time delays. Designed to directly interface with TTL and CMOS. And it can work on single or dual power supplies. You can have a single supply between 2 and 36 volts, or if you're going to split the supply, you can go, it's basically still a range of 2 to 36, but if you're going plus and minus, it's 1 to 18 plus and minus, which gives you an overall 2 to 36 difference. So here's a square wave generator and a comparator with hysteresis built in using this sort of circuit. So this is the sort of thing I'm looking for, general purpose comparator applications. And it says here you can sync an output current of 6 to 16 milliamps. And here's the representative diagram of the output open collector. So when the output is being driven, it will pull the output to ground, and you would have to have a pull up here. And because it's not being driven actively high, I guess that allows it to more easily interface with all kinds of other logic families. Quantity 10 of ULN 2003, which I believe would be Darlington output drivers. Good to have around. Never know when you need to power some devices from logic level circuits and want some transistor power behind it. Quantity 10 of ULN 2003 Darlington driver, 99 cents from World Chips. This is similar to the 2803 Darlington array that we already looked at. Same spec, 500 milliamps out, 50 volts. So the main difference being that this chip only has 7 output drivers instead of 8. It still has the protection diodes for inductive loads and can drive relays, stepper DC motors, lamps, etc. And this datasheet describes several different items. Some of them are configured differently, intending to do different things like driving from CMOS devices. The whole family generally does the same thing, so I just wanted a couple of variations on this. I have no specific intention other than if I conveniently want to quickly turn on a relay or a little motor, I can hook it up directly to some logic and straight to the output for testing. And this, it looks like I bought some rotary encoders of some kind. I got 2 of them. Yeah, they have that nudging rotary encoder feel and push button. Quantity 2 EC11 rotary encoders with a switch, 99 cents from World Chips. And here's a variation of EC11 configuration. Because this is just the encoder and it doesn't have any onboard pull-up resistors, you would need your own circuit. So terminal C, which would be in the center of the 3 pins on the one side, would have the common of both switches. And then there's terminal A and B, which are the output encoder A and B. So if these are just going to regular logic inputs on a microcontroller, Arduino, etc., without a pull-up built in, you would have to add pull-up resistors, and that's how you generate a on-off logic signal. It would get pulled high, and when you have the rotary encoder switch making contact, it pulls it low. But if the microcontroller input has a built-in pull-up, you can still just hook this up directly without any extra pull-up resistors. And the microcontroller's built-in pull-up will be the high, and when the rotary encoder switch makes contact, it grounds it out. So as you rotate the encoder, you get your phase signals. If A is detected as coming on, and then halfway through or so, B comes on, and then A goes off halfway through that cycle, you're going clockwise. And it looks like a bunch of 40 pin or so 0.1 inch headers, male pins. You can never have too many of these, but let's see if these are breadboard friendly diameters. So, supposing this short side were soldered onto an Arduino style interface, and I want to dock this onto a breadboard. Well, so it took a little bit of coaxing, but they did go in. It could also be the breadboard a little stiff because it's relatively unused, but if needed, those can go in. Standard 10 pieces of 40 pins, 0.1 inch headers, 99 cents from World Chips. I never thought I'd get through that package. This is a lot of stuff. I think I'm going to go for one more. I can't stop. All right, business and industrial time. Now what could this possibly be? Curious as to what's in here. ICs. I don't know what they are. I don't know if they're all the same. I probably ordered it months ago. Multi-purpose tool. It's a cutter and a tapper. Looks like I got CMOS chips, 4027. I know I wanted to stock up on a whole bunch of common things, 7400 series, 4000 series, and 10 pieces of 4027 CMOS chip, dual master-slave JK flip-flop. 10 for $3.35 from Superior Buy 2014. This looks like it has a Texas Instruments logo, and here's a Texas Instruments datasheet. It's just your standard CMOS old 4000 series logic chip, and this looks like a really old scanned-in PDF. So there's not much to go through on this. I just bought it because I want to rebuild my TTL and CMOS part libraries, and I'm just going to go along and fill in the blanks with what I think I might need and what I don't yet have as time goes on. I'm exhausted, my back hurts, I need to go stretch or something and then figure out what to do with all of this. And I barely put a dent in the pile. I don't know if I should do another huge mailbag like this or take the 3.5 years it'll take to just get through it bit by bit. Fun times ahead.